Interesting. If you watched AI security videos from a year or two ago, this basic ignore previous instructions attack probably looks familiar. Now look at the first line of the AI's response. The model tries to act smart. Its safety training kicks in and drops a standard refusal. I cannot provide information that goes against my instructions. Now we can clearly see Meta's millions of dollars spent very well. But does that mean that prompt injection is dead? Not even close. It's just getting weirder. Welcome to the Adversarial Analyst. This is LLM-01 prompt injection. In traditional applications, we work very hard to separate code from data. SQL commands are code. Customer names are data. Mixing the two gave the world SQL injection. Eventually, software industry solved this with parameterized queries and proper architectural separation. The data could never break out and look like commands. But LLMs work completely differently. Everything gets merged together in one giant stream of text tokens. System instructions, conversation history, retrieved web pages, internal documents, and user inputs. All of these are simply raw text to the model. The model has to try and reason on the fly about which instructions carry authority and matter the most. Prompt injection is the act of manipulating that internal reasoning process that the LLM possesses. On the left hand side, we have a traditional SQL app. In this app, the parser reads symbols. When an attacker throws in a stray code character, they are physically cracking open the structural pipe of the code, changing how the engine handles the commands. SQL injection attacks a structural parser by breaking out of syntax boundaries. On the right hand side, we have an AI. This is a fundamentally new security problem because there is no structural box or code character to break out of. The system prompt and ignore all previous instructions flow through the exact same lane as the raw text. The model reads it all, gets completely distracted by the semantic meaning of the prompt, and its internal attention shifts away from its initial training. Let's take a look at our first lab environment. Our demo application is a customer support chatbot for a fictional shoe company called SoulStyle. Notice how the code handles the data wrapper. It uses Llama's basic /API/generate completion endpoint and literally glues strings together in Python. We have the system instruction and we have the user input. This creates a flat text pipeline where the data and commands blend completely together. Here's the hard-coded system prompt in the script. You are a customer support assistant for SoulStyle. Only discuss shoes and shoe accessories. Never offer discounts larger than VIP 10. Under normal conditions, everything behaves exactly as expected. Well, look at that. This is where many old tutorials stop working. Because of extensive safety training and the millions of dollars that Meta spent, the model's built-in alignment catches the aggressive phrase, ignore instructions, and safely shuts it down. So attackers adapted. Look at the screen. The model followed our instructions properly. Not because we hacked a parser or found a software bug, but because we successfully framed the request as an innocent data processing task. This is what makes prompt injection so fascinating. Prompt injection is essentially social engineering for models. You aren't defending against malformed syntax characters, you are defending against persuasion. Because LLMs use an attention mechanism, the model got so heavily consumed by the tracking of exact letters and positions of our alphabet game that its safety training dropped into the background, and it happily generated the forbidden VIP 90 clearance token right into our interface. Direct injection via chat box is an interesting challenge, but indirect injection is where the enterprise engineering teams start getting nervous. In this scenario, the attacker never directly talks to the model. Instead, they place a malicious payload inside a document that the application is designed to read automatically, like a product review, an invoice PDF, an email attachment, or a customer support ticket. When the backend application pulls this text and passes it to Llama 3.1 to summarize, the model faithfully processes the text and executes the hidden instructions, pushing a malicious link onto an innocent user who thinks they are talking to a verified brand assistant. If your AI system can read external data sources, whether it's scraping web pages, pulling Jira tickets, or syncing Slack channels, attackers can potentially influence its behavior. To be completely transparent, there is currently no magic silver bullet that stops prompt injection 100% of the time due to how flexible language models are. But we can build a much more resilient app by shifting our engineering approach. Look at the remediated code in secureapp.py. We've made two fundamental structural updates. First, we swapped the raw text generation endpoint to the structured chat endpoint. This wraps our system prompt and untrusted user data into distinct structural containers that help the model to keep track of context authority. Second, we've implemented a strict defensive programming rule, which is never trust the model to protect itself. Even if a clever logic puzzle tricks Llama's reasoning brain into generating the token, our backend Python code catches the phrase VIP90 right as it exits the model, shutting down the data leak before it can ever reach the user browser. Everything we used today is ready for you in the repository inside the LLM2 folder. You'll find the vulnerable app configuration, our verified alphabet game exploit script, and the secure implementation code. Clone the repository, spin it up against your local Llama instance, and see it run on your own machine. Try tweaking the payload to see if you can find a way to trick my secure output check. In our next video, we are moving to the next major risk on the list, sensitive information disclosure, where we'll look at how corporate databases accidentally leak private data through chat. See you there.